So when it comes to triangles, we know that interior angles of a triangle add up to 180 degrees. All right. So that means if I've got x, y, and z, x plus y plus z equals to 180 degrees. And another thing is, if we extend one of the sides of a triangle, we end up with what is known as an exterior angle. And this exterior angle here is equal to the sum of these two interior angles. And they opposite to that angle. So the exterior angle is equal to the sum of the opposite interior angles. That would be that, and it would be those two added together become that. All right. Another thing about triangles, we can have different types of triangles. So you got your all three sides are equal, known as an equilateral. One of the sides is different and the other two are equal, becomes an isosceles. And if you have all three sides which are different lengths, it's called a scalene. So this is known as a scalene. This one is equilateral. And this one is isosceles. We use this dash to show that all the sides are equal. These two are equal, that one is different. So we need to put 2 over here. This one, they're all different. So they'll all have different dashes. Because all the angles are equal, each of these have to be 60 degrees because angles in a triangle add up to 80. If you got theta plus theta plus theta becomes 3 theta, then that will equal 180. So we know that theta will equal 60 degrees for an isosceles triangle. So that's the standard background knowledge, 60 degrees over there. These two angles are always equal as well. We don't know what they are, but if they're given at any point in time, then angle A must equal then angle B for that. This is an obtuse angle. It can also be, doesn't have to be obtuse, that can be obtuse as well. All right, but that's the scaling. All the sides are different for that. All right, we can then place these triangles inside a circle. If you place a triangle inside a circle and you run it through the diameter, like that, if that's the diameter and you create a triangle from there, then we end up with some circle theorems, right? And we say that the angle formed from a diameter is a right angle, which means that this angle will be 90 degrees if this line is a diameter. And that goes to any point. So you can extend this line anywhere on a circle into a triangle like that, and it will always end up at some 90 degrees or the other. Okay. Angle formed from a diameter is a right angle. Another triangle circle theorem is if you have a triangle and it's inside a circle and there's a tangent involved, and the tangent meets up at one of the corners of the triangle. So for this one here, we say that the angle from the tangent to the chord is equal to the angle subtended by that chord. The angle between a tangent and a chord is equal to the angle subtended by that chord. That means subtended meaning that this chord over here is opposite that angle. We would say this angle between this chord subtends this angle over here, so those two will be equal. So this angle equals this angle, and this one over here equals this one over here. This is known as tan chord theorem for short, or by definition, the angle from a tangent to a chord is equal to the angle subtended by that chord. All right, those are triangles in circles, and this is a combination of circle geometry and triangles as well in it. Another thing to point out is that if you have a circle and you draw a triangle from the center where two of the sides of the triangle is equal to the radii, it's worth pointing out that if this is the center of the circle C, and this is your radius, and this is also your radius, then they're equal, right? So then this triangle here ends up as an isosceles triangle. And so this angle will equal that angle over there. So a triangle formed from two radii is isosceles. All right, the previous one, remember the angle from the diameter is 90 degrees. All right, this one is shortened. The shortened version is sometimes known as angles in a semicircle. The shortened version of this theorem is tan chord. This one here. The shortened version of this one here is radii equal, depending on the question. You would also state isosceles triangle. This is when asked for reasons. So if not asked for reasons, you just need to know it and how to get the angles from there for that.